Hello, welcome everyone. In this video, I'm going to go over lines that are either parallel, perpendicular, or intersecting. So let's go ahead and start with our first example. Here we have two lines, and we want to see if these lines are parallel, perpendicular, or they're intersecting. So for a parallel line, we know that the slope has to be same. So m1 has to be equal to m2 for parallel line. That's a parallel line. Okay. For perpendicular, we know that m1 has to be equal to negative reciprocal of m2. Okay, so the slopes have to be negative reciprocal. For intersecting, just m1 is just not equal to m2. So then they're just intersecting. So let's take these two lines and see if these lines are parallel or perpendicular. So the first line, we have this 3x plus 1. So m is equal to 3 for the first line. The second line, we have y equals negative 1/3 x minus 2. So m2 equals negative 1/3. So now let's see, is m1 equals m2? Is 3 equal negative 1/3? No. No. Is m1 equals negative 1 over m2, negative reciprocal? We have to solve for that. So we take m1, which is 3 right here. So m1 equals 3. And we take the reciprocal of that, becomes 1/3. And then we take the negative of that, which is negative 1 times 1/3. It becomes negative 1/3. Okay, so the negative reciprocal of 3 is negative 1/3. So yes, m1 and m2 are negative reciprocal, so lines are perpendicular. Okay. Now, how do we solve for that point where they're intersecting? Okay, so for that, we set our y1 equals y2, and we solve for the x value. So we have two lines, so we set y1 is 3x plus 1, and we set that equal to negative 1/3 x minus 2. So we do that, and then we go ahead and solve for x here. So here is a 1/3. We have a fraction, so we multiply the whole equation by 1/3. So then we go ahead and do that by 3. So then we get 9x. When we multiply 3 by 3x, we get 9x. When we multiply 3 by 1, we get 3. When we multiply 3 by 1/3, we get just negative x. And when we multiply this 3 by negative 2, we get negative 6. Okay. And then we go ahead and simplify this right here. We're just going to subtract 3 here and here 3 here, so we can move it on one side. So we have 9x equals negative x minus 9. And then we go ahead and we have 9x equals negative x minus 9. We add x on both sides. Okay, on both sides of this equal sign. So we have 10x equals negative 9, and then divide by 10. We get x equals negative 9 over 10. So now we have that, our x value, then we can go ahead and solve for the y value. So we plug in into one of these equations. So I'm going to plug into this first equation. So y equals, just going to make a little space here. Y equals 3, and for x I'm going to plug in negative 9 over 10 plus 1. So this becomes negative 27 over 10 plus 1. And then we go ahead and simplify this. This becomes negative 27 over 10 is negative 2 negative 2.7 plus 1. So you're left with negative 1.7. So this is the point right here. So you have your x value is negative 9 over 10, comma, y value is negative 1.7 right here. This is the intersection right there. All right. So once you know that lines are parallel, they will never intersect. So there's no need to find the intersection after that. But if the lines are perpendicular, are they intersecting? Well, once you find out they're perpendicular, their slopes have to be negative reciprocals of each other. Or if they're not negative reciprocals, then lines are still intersecting if the slopes are not the same. So then you have to go ahead and solve for the point of intersection to find out the coordinates of the intersection. So it's a little bit more lengthier. Let's do the next one. So for parallel, perpendicular, or intersecting, for parallel, M1 has to be equal to M2. For perpendicular, M1 is equal to negative 1 over M2. For intersecting, M1 is not equal to M2. That's just so these are the three things that we look for here. So the first one, we know that y equals 3x plus 4, and we know that the M1 equals 3 from this equation. The second equation is negative 2x plus 4y equals 12. Okay, and then we go ahead and solve for y. So we add 2x here plus 2x here. So we have so 4y equals 2x plus 12, and then we divide by 4 to solve for y. We divide everything in the equation by 4, so this is y equals 1/2 x plus 3. Okay. Now we know that M2 equals 1/2. Okay. So is M1 equals M2? M1 is 1. M1 is 3. And M2 is 1/2. No. Are they negative reciprocal? Is M1 equals negative 1 over M2? Well, let's see if that's true. So we go ahead and M1, we take M1, which is 3. We take the reciprocal of that is 1/3. Then we multiply it by negative 1. Becomes negative 1/3. So is that true? M1 and M2? No. So M1 is not negative 1 over M2. So they're just intersecting. Okay. Now let's find out the point of intersection. So for that, we set up this equation equals to this equation. So we set y1 equals y2 and solve. So y1 is 3x plus 4, and y2 is 1/2 x plus 3. Okay. Now to eliminate this denominator, we multiply the whole thing by the denominator, which is 2. So this becomes 6x plus 8 equals 2 times 1/2 is just 1x plus 2 times 3 is 6. So now we go ahead and solve this. We subtract 8 on both sides. Okay, and so this is, we subtract 8 on both sides. So this is cancelled, and we're left with 6x equals x minus 2, and we subtract x on both sides. This is 5x equals negative 2, and then we have divided by 5, so you get x equals negative 2 over 5. And now we can solve for the y once we have the x. So we're going to plug in into one of these equations. So y equals 3, so I'm plugging in here, negative 2 over 5 for x plus 4. Now if we solve this one, we get there's not enough space, so we get negative 6 over 5 plus 4. And if we simplify this one, we get 20 minus 6 is 14 over 5. Okay, so which would be about 2.8. 2.8 if you simplify it further. 2.8. So this point right here is the x value is we already figured out what's the x value is, negative 2 over 5, and the y value is 14 over 5, which is 2.8. Hopefully this helps.